let's go to LeetCode 600 non-negative integers without consecutive ones. For this question, it gave us integer n and ask in the range from 0 to n, how many binary representations don't have consecutive ones, and the 0 n are included. So let's look at n equals 5. Let's say 5 is 101, and from 0 to 101, 0, 0, 1, 1, 0, and 3 has consecutive 1. We cannot count it. So 4 and 5, right? 1, 0, 0, 1, 0, 5, 1, 1, 1. So there are totally 5 numbers, so it will return 5. First thing, what we think about is that we want to calculate for length I, a binary representation for length I. How many representations, number of representations don't have consecutive ones? So we'll see for length 1, right? Length 1, we can have result 0 and 1, right? And actually for length 2, length 2, so there are 2 representations. For length 2, we can have 0, 0, 1, 0, and 0, 1, right? So there are 3 representations. For length 3, we can have 0, 0, 0, 1, 0, 0. And 0, 1, 0, right? And also can have we can have 1, 0, 1, and we can have 0, 0, 1, right? 0, 0, 1, and 1, 0, 1. So we'll see for every so we'll say we can create something called a DPI. DPI will represent for length I how many number of consecutive how many number of representations, binary representation which does not have consecutive one. We'll say DP1 equals 2, DP2 equals 3, DP3 equals 5. Now it looks like the DP3 equals DP1 plus DP2, right? So let's try to see so let's try to see whether we have, looks like this number is from the previous 2 numbers, calculate from the previous 2 numbers, right? So actually we know for DP3, if the last number is 0, right? We can use the previous one. Previous one does not have consecutive ones. We just append a 0 into it. So we'll say DP3 will be at least DP2, right? And add something, add this one. This one is the last number is end with 1, right? End with 1, that means the previous one can only be 0. So this one, we can choose only here, right? Can be, that is DP1, right? So we'll see for any DPI, for the last index, it can be 0. Then this number of representations can come from DPI minus 1. And if this is 1, right, that means the previous one can only be 0. Then we can have dpi minus 2 for this kind of representations. So that will be dpi minus 1 plus minus 2, right? So this is like house robber. If we cannot have consecutive ones, that means if we rob current one, then previous we cannot rob. So that is dpi minus 2. If we do not rob, right? So we can transit from dpi minus 1 to current 1. So we'll say the first step is we calculate for length I how many binary representations which do not have consecutive ones, right? So we know dpi equals dpi minus 1 plus dpi minus 2. So we are going to create an dp length 32, right? Because we know for every number, there are not more than 32 lengths. So what's the initial value, right? We know dp1 equals 2, right? The length is 1, and the dp2 equals 3, right? dp3 equals 5. And so we can calculate what is dp0, right? dp0 will be 1, right? This is the dp0 to be 1 is just used for calculations. So we can write for int I equals 0 equals 2, I smaller than 32, I plus plus dpi equals dpi minus 1 plus dpi plus 2, right? I minus 2. So the second thing we want to do is that for this kind of number, we want to convert this one to be an integer array, a binary array. For example, if it is we call it the num, right? New int 2032, right? So for example, this is a 5, right? 5, we know that is 101, right? So we'll have we'll convert this one as 0, 0, 0, and 1, 0, 1, right? So there are 32 elements. So if 5, we're going to convert as this. So for this n, right, let's convert to this kind of integer array. So we know the bit for int j equals 0, j is smaller than 32, j plus plus. So we'll say if one left shift j positions and number and this n, right? This one, if this one doesn't equal to 0, that means from the right, from we count the j position, it will not it will be 1, right? So we'll have nums 31 minus j equals 1, right? So in this case, we convert this number into a binary array. So our result will use these two we want to use these two parts, calculate how many binary representations from this kind of 0 to n, right? So let's look at, for example, I have a number I represent this one as 0, 0, something, and I, and for example, there is for this I index, it's the 1, right? And possibly some kind of 0, 1, 0. So we iterate from the left to right, trying to see which position have 1. For example, at the index I, it is 1, right? So we know for any number from 0 to this kind of length, right? So we know that for this kind of length of binary number, it will always be smaller than our number. So that means that means for example, this is I, right? So on the left, that is I plus 1, right? So on the right, that is 31 minus I. So for 31 minus I length 31 minus I, we have dp 31 minus I representations do not have consecutive ones. And this kind of number are smaller than our n, right? So that means you can write anything like for example 101 in this and put here as 0, right? And put the previous one as 0. They all smaller than our n number. So so if we have an I here, we add the rest of the length. So the optimal so we keeping iterate from left to right. The optimal the situation for us is that everyone is separate with some kind of zeros, right? So in that case, if there is no consecutive ones, or no consecutive ones, we just iterate those kind of I, right? And add the length, which is 31 minus I, add to our result. And what we add is if we iterate from the left to right, and we didn't make any consecutive ones, we added them together, and all of those consecutive ones are smaller than our current number, right? So we still need to count our current number as one of the results. So it will keeping, for example, where result at equal to BP 31 minus I, right? If there is no consecutive ones, we're keeping adding this result. And if we iterate to the end, there is no consecutive one, right? We should add the number itself. So the result will plus 1, right? But if there is another situation, is that there is consecutive one in this array, right? So for example, we have 1 and 1 and blah blah blah, right? And for example, for this one, we'll see we add this one. The first one is that we add this kind of length, right? For example, this is the second one we call index I, okay? And the first one is index I minus 1. If both are 1, right? So this is we add this kind of length, and also we add this kind of length, right? So we'll see for we add the consecutive ones. the number we are going to add can only it will smaller equal to our result, right? So so the first number can either be 0 or 1, right? So if it is 0, that is the dp I minus 1, right? dp 31 minus I minus 1, right? So this part. And if it is this is 1, right? The next part can only be 0 because we cannot have consecutive ones, right? So this can only be 0. So what will add to our result is this is I, right? dp 31 minus I. So we add this, then we should return. Because we don't need to add any result anymore because this is not allowed, right? And we can have 0 or blah 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 or 1 0 and any of the 1 0, right? All of the 1 0 situation add to our result, and all of the situation 0 and start with 0 and the rest binary, and all of the situations start 1 0 and the rest of binary combinations, right? So that will be our result. If we have two consecutive ones, then we just add this part and then add this part, then we return our result. Just as we mentioned, let's begin to write code for this. So we'll have int result equals to 0. So what we're going to do is for int I equals 0, I smaller than 32 plus plus. So if nums I equals 1, right? We are firstly result add equal to dp 31 minus I, right? And as we mentioned, if the I is 1 and its previous in the previous number is the binary is also 1, right? Then we should when we add this, part, we should return. We should stop. So I say if I doesn't equal to 0 and nums I minus 1 is also a 1, right? So we just return result. And when we iterate the whole for loop, we didn't return result. That means for this kind of integer array, there is no consecutive ones, right? So all of the ones are separate. In this case, we should add this number itself, right? Because it itself does not have consecutive ones, so it will return result plus 1.